Hello guys, how are you? Today we're going to talk about missing values and how to get rid of them. First, we're going to work with a dataset named Titanic, which is pretty popular. But if you don't know and you don't have it, you can download it on this address, which I have already included in the description section. Um, we're gonna go through the code, but you can take a grasp on how any of columns mean. So you can take a look at this one so that you can get a basic understanding of each and every columns, but it doesn't matter so much. And let's cut to the chase. And first one, we have deleting rows. Let's take a look and see how we can implement each missing value um, methods. So first I import numpy as np and I import of course pandas as pd and I define my data frame which is pd dot read csv and mine is Titanic dot csv. Okay, let's take a look. All right, we have this 5 as our head, and I'm going to get a length of my df, which is 891. So, as our first method, I'm going to attempt to delete missing value rows. Okay, I make it markdown. So how do we do that? First, we take a look at our null rows and get a sum, of course. As you can see, we have 177 null rows for age column and 687 for cabin and 2 for embarked. So how can we approach this method? It's pretty much easy. You can simply say df dot drop na and in place equals true so that it takes place in our data frame and hit enter. Actually hit shift enter or shift return for Mac users, and as a result if I say df drop na or actually is null and get the sum, you can see there is no missing values in our data frame anymore. And let's take a look at length. Yes, we get down from this one to this one just because we deleted our missing value rows. So what about pros and cons? For pros, we can say results are robust and highly accurate because we don't have any missing value rows, and since it doesn't have a high vintage. And for cons, we can say loss of information and data works poorly if the percentage of missing values is high, for example 30% and above. So let's go to the next method. We can replace missing values with mean, median, and mode. You can see and search about the differences between three of them, but we can simply go with mean actually. Let's do this. I copied this one because we want a fresh data frame. Okay, and actually before that I'm gonna say method 2 replacing with mean slash median slash mode. All right, there's that. And let's take a look at our age column and see how many null does it have. So 177. We can simply say df age dot mean. All right, and the mean of our age column is 29.69, approximately 30 years old. Okay, so how can we replace our missing values with mean? It's simple, like this. df age replace, and we say np.nan, then df age dot mean. Okay, so we can do it like this if we want. We can say age dot median or mode for that matter. It doesn't matter. We have some differences, but it has something to do with the definition of these two. Okay, now that we did it, we can simply copy this one. Yes, we do have that because we have to say df age is equal to this one. Okay, now if we copy and paste this one, you can see we don't have any missing values anymore because we have replaced it with our mean. And we can simply say df age, let's say head, and get 10 of them. As you can see, we don't have any missing values anymore, and we replace it with our mean. Okay, let's go to our presentation. As pros, we can say this is a better approach. When the data size is small, it can prevent data loss, which results in removal of the rows and columns. But imputing the approximation at variance and bias and works poorly compared to other multiple imputation methods. So the main problem with this approach is with that we have more bias and even more variance, and that is not our desire. So let's go to the third method, which is assigning and unique category. Okay, let's see how it can work. Let's say df cabin. We can see our cabin first. As you can see, it's a categorical feature, so we can put a unique category for our NaN rows. How can we do that? It's pretty simple. We can say fill Na with a unique category, which can be anything you want. I'm writing U for an example, and I can get head right now. As you can see, we have changed our missing values with U. Okay, so for assigning an unique category, you have less possibilities with an with one extra category, and you can get low variance after one hot encoding. Since it is categorical, negates the loss of data by adding an unique category. And for cons, we can say adds less variance, adds another feature to the model while encoding, which may result in poor performance if your model is highly dependent on that categorical feature, which is cabin in our case. So for the next one, we can say predicting the missing values. For this one, there are tons of ways to do it, but we're gonna take a simple approach actually. We load our data frame and we say df age dot interpolate with method linear, and of course in place is equal to true. What it does is that it interpolate our data frame, our age column, with linear regression. And let's see what happens after we do it. Okay, we cannot get this one, and actually I have to assign it to our age column. And after that, I can say age dot head. Okay, we get none actually. And why is that? Let's do it like this. Still getting none. Interpolate method linear and in place. Something is wrong. I'll say let's import this one again and this one, and I can get the head of our our data frame. As you can see, we don't have any non-values in our age. We can even go further. You can see all is filled with linear interpolation. Okay, all right. Imputing the missing variable is an improvement as long as the bias from the same is smaller than omitted variable bias yield. Unbiased estimates of the model parameters. And as of cons, we can say bias also arises when an incomplete conditioning set is used for a categorical variable considered only as a proxy for the true values. So it's a better way comparing to actually replacing with mean, but it's not the perfect uh, way to do it. And as of our last method, we can say using algorithms which can work with missing values. Okay, KNN is a machine learning algorithm which works on the principle of distance measure. This algorithm can be used when there are nulls present in the dataset. While the algorithm is applied, KNN considers the missing values by taking the majority of the k nearest values. In this dataset, taking into account the person's age, sex, class, etc. We will assume that people having same data for the above mentioned features will have the same kind of fare. Unfortunately, the scikit-learn library for the k-nearest neighbor algorithm in Python doesn't support the presence of the missing values. Another algorithm which can be used here is in random forest. This model produces a robust result because it works well on nonlinear and categorical data. It adapts to the data structure taking into consideration of the high variance or the bias, producing better results on large data sets. And as for pros, we can say it doesn't require creation of a predictive model for each attribute with missing value or replacing it with mode median or mean or even deleting the rows, which can result in poor results actually, but it's a very time consuming process. Here it is. We covered all 5 possible ways to cover our missing values. I hope you liked it. If you do, please like the video and subscribe.